Alright, let's divide some radicals. In a previous video, we talked about adding and subtracting radicals. We also talked about multiplying radicals and the process behind that. Dividing radicals is a lot like that. First, you want to divide the outside by the outside and the inside by the inside, and then you're going to simplify the resulting radical. Let's just take a look at an example right away so we can kind of talk about that in real terms. Here we have 12 times the square root of 160 divided by 2 root 5. So what that's going to end up looking like, outside by the outside times the square root of 160 divided by 5. Well, we know we can simplify the outside here. 12 divided by 2 is 6. And then 160 divided by 5 is 32. That is not its fully simplified form, but we're getting there. 6 times the square root of 32. Highest possible radical there, or perfect square, is 16 times 2. Square root of 16 is 4. 6 times 4 times the square root of 2. That can be simplified to its furthest point. That's 24 root 2 as a final answer. Nice. When it works out like that, it is very convenient. But there are a few rules we need to follow. Rationalizing the denominator. So after simplifying, there should be no radicals left over in the denominator. So if you end up with a final result like 6 over radical 2, that's not something that we're going to be able to do. The process of removing any leftover radicals from the denominator is called rationalizing. We would need to rationalize something like this. There are two types of rationalizations we need to do. A monomial denominator, so 3, say 3 over the square root of 6. We have one nomial on top, one on bottom. You're going to multiply the top and the bottom by the radical to get rid of that. We'll go over that in a moment. If you have a binomial denominator, so two different things like, how about 4 over 1 plus the square root of 2. You're going to need to multiply top and bottom by the conjugate of the denominator. Conjugate's going to be our big word of the day. The conjugate is the same expression, but with a different sign. So it would look here if you had 2 plus the square root of 5, the conjugate would be 2 minus the square root of 5. It's going to be really important. Make sure you have that written down. So let's look at examples. I think that's the best way. Here we got to simplify 3 divided by 2 times the square root of 5. This is a monomial because they're just being multiplied together. They're all together. There's no other operation there. 3 over 2 root 5. So what we need to do is multiply both sides, top and bottom, by the square root of 5. So I'm going to pause here and think about the square root of 5 times divided by the square root of 5 is 1. All we're doing to rationalize this is multiplying it by a very creative version of 1. Wow, what a terrible circle that was. And we're going to multiply straight across because that's what we do with fractions. We're going to be left with 3 root 5 on top. On the bottom, let's think about this. It's going to be 2 times 5. We know that because the square root of 5 times the square root of 5, we know we do outside by outside and by inside when we multiply radicals. This would end up being the square root of 25, which would be 5. We are almost done simplifying here. 3 root 5 on the top, on the numerator, is fine. The denominator does not have any more radicals, but we can multiply 2 times 5 and get 10 as a final answer. All right, that's all well and good. Multiplying by a creative version of 1 here. But if we need to use the conjugate, what is that going to look like? Example 3, 2 over 6 minus the square root of 5. Okay, so we've got, binomial here, we've got two operations, or two things going on. Not two operations, just one operation. So we're going to have to be a little creative here in how we rationalize this. We're going to do multiply by the conjugate. We see a subtraction symbol here. So we're going to multiply the top and the bottom by 6 plus the square root of 5. 6 plus the square root of 5. We are again multiplying by a creative version of the number 1, because this divided by this is 1. And from here, we're going to have to factor when we multiply. So that is, we have to make sure we're paying extra attention to that. Let's do the numerator first. 2 times 6 is 12. 2 times square root 5 is 2 root 5. And on the bottom, we've got, I'm trying to use different colors here. That's a good idea. 6 times 6, which would be 36. And 6 times the square root of 5 is going to be plus 6 root 5. And another color still. Negative square root of 5 times 6 is going to be minus 6 root 5. And the negative square root of 5 times the square root of 5 is simply going to be minus 5. All right. That was a lot of distributing practice there that we haven't done in a minute, so that's nice. On the top, we have 12 plus 2 times the square root of 5. Those are not like terms, so we can leave that as it is. On the bottom, though, here, we have positive 6 square root of 5 and negative 6 root of 5. Those are going to cancel out very nicely. And 36 minus 5 is going to leave us with 31. So my final answer here is going to be 12 plus 2 times square root of 5 over 31. That cannot be simplified anymore. There aren't any radicals in the denominator, so we have simplified this to the furthest point.